the third of our forms of linear equations that we have to know. So real quick, see if you can remind me if I ask you for slope-intercept form. For a linear equation, what is that one? Good. What if I ask you for standard form? Okay, ax plus by equals c, and they're capital. A, B, and C are capital here, right? Those parameters are capitals. And then last one, you're going to have to memorize all these. We're going to have a quiz coming up over this at some point here fairly soon. What's the slope formula? What's m equal to? y2 minus y1 over... Good job. Okay, so today we're going to introduce a new one. Today we're introducing the point slope formula. Now, slope-intercept is typically the form we want our answers to be in. Y equals mx plus b. That's the simplest way of writing the equation of a line, but we don't usually get to start there. Starting there would make it a pretty simple problem. If you knew the slope and the y-intercept, if you knew m and b, and all you had to do were plug those numbers in for m and b, that's a pretty quick problem. It's one step and you're done. Usually we don't know that. Usually we know or we're able to calculate a point on our line and we know the slope of our line or can calculate the slope of our line. So usually those are the starting places, and so we need a formula that allows us to start there. Well, that's what this one does. The point slope form of a linear equation means we're going to input the coordinates of a point and we're going to input the slope into the formula, and then from there we can do a little algebra to turn that into slope-intercept form. Okay? So here it is. This is the point slope form of a linear equation, or the point slope formula if you want to call it that. Y minus y1, which is just the y coordinate of some point that I know, right? Here's a point, x1, y1 are the coordinates of some point that's on our line that we know. So we're going to input the y coordinate there and the x coordinate there. We replace x1 with the x coordinate, and m, of course, is the slope. We plug in the slope, replace the m with the slope, and we got it. Okay? So let's try one of these first of all. So for this blue line, can anybody tell me what the slope is just by inspecting the line? 3/2. Yeah, I agree, right? We're just making a slope triangle, aren't we? If we go from the first point to the second point, we're going to rise by +3 and run by +2. So our slope, m, equals 3/2. Okay, now we need the coordinates of a point. So our point, x1, y1, would have what coordinates? Well, we have 2 points. You can really take your pick. Either one of those would do. Let's go ahead and use this bottom one. Everybody agree its coordinates are -4, +1, right? So those are just going to be the values of x1 and y1. And then all I have to do is just plug that stuff into point slope form. Okay? So what's that going to look like? So we always start off with our formula. y minus y1 equals m times the quantity x minus x1, and we'll just plug numbers in. So what numbers go where? What goes in for m? Yeah, so 3/2 is the value we're plugging in for m. What value are we plugging in for x1? -4. What value are we plugging in for y1? 1. Okay, and what do we get? If we do that, we just get y minus 1 equals 3/2 times the quantity x minus negative 4. So what's that become? Plus 4. Okay, so we're done with point slope. Now all we have to do is just simplify that, and the steps are always the same. The steps to go from point slope to slope intercept are always going to be, first we distribute the slope. We're just doing PEMDAS. First we distribute the slope, and then we add or subtract this number to the other side, depending on which one we need to do every time. Okay, so let's wrap this up. Let's do that, and then you can try one of these. Okay, so what happens if I distribute my slope? What am I going to get? I still have y minus 1 on the left side. What do I get when I distribute to the first term? 3/2 x. And then 3/2 times 4, which remember, that's the same thing. If we think of it as a fraction, as 4 over 1. So I'm multiplying. How do I multiply fractions? Straight across, yeah. So I'm going to get 3 times 4 is what? 12 divided by 2 times 1 is 2. Well, what does that simplify to? 6. Okay, good. So then we just get plus 6. Good. Last step. Add 1, and we're done. Okay, I'm not going to mess with this. I don't think we need to. We'll come back and review this stuff later. Let's not get bogged down with that now. Okay, so if we add 1 to both sides, we get our final answer. Y equals 3/2 x plus 7. There's our line in slope-intercept form. Good? Okay, go try one. Okay, what about one like this? Now, every problem we do today is just going to be trickier and trickier versions of the same exact question, right? So we're just going to figure out some way that we can plug in to point slope the coordinates of a point and a slope. We may not be given all that stuff directly, though. We may have to calculate part of that. So this time we're supposed to try to find the equation of the line that goes through those 2 points. So what am I missing here that I need for my point slope formula? I need a slope, right? They didn't give me the slope directly, but I can calculate it. Okay, you reminded me just a little bit ago of what the slope formula is, right? So what is my slope? What am I going to subtract on top? Say it again, 7 minus 4. Okay, what else could I do? I could actually do 4 minus 7 if I wanted to, but then I just have to be consistent on the bottom. 7 minus 4, that makes more sense because we're calling this point 1 and then the right one point 2. So we're going to do right coordinates minus left coordinates for the y's, so we have to do the same thing for the x's. We just have to treat it the same on the top and the bottom, use the same pattern, right? Be consistent. So what would I subtract on the bottom then? Okay, good. So that's going to give me, what, 3 on the top, 9 on the bottom, and what does that reduce to? 1/3, okay. So there's our slope. That's good. Well, what else do we need for point slope? We need a slope and a point. Okay, well, what point are we going to use? What do you think? Yeah, I could pick the first one. I could use 6, 4 as my ordered pair. Or what else could I do? Doesn't matter, either one. I just need a point that's on the line. First one seems a little easier though. They're smaller numbers, so let's use that one. So we're going to call this one x1, y1. And then all we have to do is just plug into our formula, right? So I'm going to get y minus what number? 4, okay? Equals what slope? 1/3 times the quantity x minus 6. And the steps from here are always the same. What do I do first? Distribute. Yeah, okay, good. So what, 1/3 x? What's 1/3 times 6? Everybody agree? 2. 1/3 of 6 is 2. Last step, add 4. And we get y equals 1/3 x plus 2. Good? Okay. Go try one. What are we going to do first here? We're going to find a slope, aren't we? Yeah. Okay, so let's do that. What am I subtracting on top? Good. On the bottom? Uh-oh. Okay, what's that mean? That's not gonna, okay, yeah, so it's gonna be one of the weird lines, isn't it? Now think about this one. Dividing by 0 means that the slope is what? It's undefined. Now which line has an undefined slope? Vertical line, not a horizontal. What's the slope of a horizontal line? 0, yeah. How do we remember that? A couple ways to think about it. Well, for one thing, you guys probably remember, did you call it no slope back in the day when you had a vertical line? You didn't? Okay. Well, think of it this way. This is rise over run, isn't it? Right? That's what slope is. Between those points, I'm rising by 7 vertically, and I'm running by 0. Well, running by 0 could only happen on what kind of a line? That'd have to be vertical, wouldn't it? Between the 2 points, I'm not moving horizontally at all, right? So we know that has to be a vertical line. The other way you might be able to kind of, something that's consistent that'll help you remember this. A vertical line is going to be the line that we can't write as a function, right? Because it fails the vertical line test. A vertical line is going to intersect a vertical line in an infinite number of places. And so it's not a function. And so I couldn't even use the point slope formula to build a line that way. And I can't because there's no slope to plug in. What's 7 divided by 0? Well, you can't do it, right? It's nothing. You can't divide that. So that's another way to remember this. The other way you could even think about it is if you just look at these points, you maybe could have even avoided the whole process. What do you notice about the x coordinates? They're the same. Picture in your mind here what that looks like in the xy plane. If I have 2 points with the same x coordinates, how do they have to line up? They have to line up vertically, don't they? If they have the same x coordinates. Okay, now remember, if we have a vertical line in the xy plane, a vertical line is going to cut through which axis? The x-axis. So it's named by x, right? That's how we always remember that. We always remember that vertical lines and horizontal lines are the really simple equations. They're the x equals a number and y equals a number equations, right? The trouble is just remembering which one is which. Well, the easiest way to remember it is, in your mind, just think of a vertical line. Which axis does it cut through? The x-axis. So it's going to be an x equals equation. A horizontal line cuts through which axis? The y-axis. It's parallel to the x, but it cuts through the y. So this one is going to be a y equals a number equation, right? How do we get the numbers? Well, they're just going to be the y-coordinate of every point on the horizontal line or the x-coordinate of every point on the vertical line. So we know that this one has to be an x equals a number equation, what's the number going to be? What does x always equal for every point? 2. You got it. Equals 2. Okay, makes sense? Give me thumbs on that. Does that make sense? Those are quick problems to do. There's no algebra, right? But you just have to practice them a few times to kind of really get that straight. Okay, last questions. We'll work through these together. So what about this one? These are going to be a little trickier. You got to think about the relationships we've talked about here over the last few days. We're supposed to write an equation in slope-intercept form for the line that passes through the blue point with coordinate 6, 4, and it's parallel to, our line is going to be parallel to this other line, this red line that passes through these 2 points. Now, what are the ingredients I need to build this line? Slope and a point, yeah, okay. So what's our point? 6, 4. Could I use these points for our point? But I can't use them for my point on my line, can I? Everybody get that? Because those are not points that are on my line. Those are points that are on some other line. Everybody see that? Okay, so then the coordinates x1 and y1 are right there, 6 and 4. What about my slope, though? How am I going to get the slope? Okay, if it's parallel to the red line, then their slopes are equal, right? So if I calculate the slope of the red line, my line's going to have the same slope. So let's do that. What's my slope? Okay, everybody agree? -4, so I'm subtracting y value. So right y value minus left y value over the same as 9 plus 9 then, right? Subtracting a negative. Okay, so that gives me -12 over 18. What does that reduce to? What could I divide into both top and the bottom? 6, yeah. So my slope is equal to then what? -2/3? Okay. And so how am I going to do this? I've got to plug in to my equation y minus what number? Okay, good. 4 equals my slope times the quantity x minus 6. Okay, and that's going to give me the line through this point, isn't it? Okay. If I want to see a picture of that, there's the picture, right? Okay, that's the line we're finding. And then all I'd have to do is just distribute the slope. So I get what? Y minus 4 equals -2/3 times x. And what's -2/3 times -6? It's going to be, yeah, everybody get that? Because if I multiply straight across, that's the same thing as 6 over 1. So if I do that product, -2/3 times -6 over 1, that's going to give me +12 over 3, which is 4. And then finally, last step, just add 4 to both sides, and we got it. Y equals -2/3 x plus 8. Okay, let's see if that works. So what should my y-intercept be then? Everybody? 8, because this is in slope-intercept form, and the slope should be -2 over 3. Let's just see if that works. Yeah, look at that. It looks like there's 5, 6, 7. There's my y-intercept at 8, and my slope is going to be, I rise -2, and I run 1, 2, 3 to get a second point, it worked. That's my line. Okay, give me thumbs. How we doing? Okay, last one. I'll turn you loose. Okay, so now we want to write an equation that goes through this point, 12, negative 4, perpendicular to this other line. Okay? So we got to figure out the stuff to plug in for y1, x1, and m. What can I do? Yeah, okay, so where am I going to get the coordinates x1, y1? Oh, right here. Yeah, that's the point. That's a point on my line. Good. So that's my y value, that's my x value. Okay, what do you think here? Let's, Serenity, how am I going to get my slope? What's the slope of this other line? Okay, well then what's the number? Slope's going to be a number. What's the slope? -2, right? So the slope of this line, it's in slope-intercept form, isn't it? So the slope of this line is -2. How's that important to me? What do you think? Any ideas here? Okay, yeah, what do I do to get perpendicular slopes? I switch the sign, flip the fraction. Okay, so this is the slope of the perpendicular line, and that's my little symbol for perpendicular. It's like an upside down capital T. So my slope then, if that's a perpendicular line, my slope has to be positive or negative? Positive, and what's the reciprocal of 2? 1/2, there we go. So mine's going to be 1/2 for my slope, which gets plugged in there. And so we just get y minus -4, so that's y plus 4. Over here I've got x minus 12, and my slope is 1/2. From there it's smooth sailing, right? If I distribute that slope, what am I going to get if I distribute the 1/2, everybody? Okay, and then last step, subtract 4. So what am I going to get? 1/2 x. There it is. Done. All right, the assignment should be up there. Jump in. You can work a little bit.